We're ready to rock 'em and roll 'em here. Applied Math Daily Lesson number 3. We're going to look at two kind of sets of equation problems, and we're going to take a look at another type of geometry connection. Our first 4 examples here, there isn't anything new to say as compared to daily lesson number 2. The only thing we have here are more challenging examples that are going to just require more operations, and you're going to have to pay close attention to detail. So as I look at the first example here, I've got distributive property, like terms, and just the whole shebang here. So the best thing you can do is just not be in a hurry. Take your time, step by step, inch by inch, and make sure that you are combining like terms, using your inverse operations when necessary, and your arithmetic. Take it slow. So I'll start with the distributive property. 4 times 1 is 4, minus 4x, and I still have my plus 3x. That's going to equal on the right side, multiplying negative 2 times x, negative 2x, and then negative 2 times 1 is negative 2. Left side, I have got like terms. This negative 4x and 3x is negative 1x, or just negative x. So I have 4 minus x will equal negative 2x minus 2. I'm going to add 2x to both sides. I'll have 4, negative 1 and 2 makes 1x, so 4 plus x will equal negative 2. Subtract 4 from both sides. I'll have x equals negative 2 minus 4 is negative 6. Example 1, DONE, done. Taking a field trip over here to example 2, a similar scenario where I'm going to have to distribute on both sides of the equation. So negative 3 outside in to 4x, I'll have negative 12x minus 3 plus 6x is going to equal, on the right side, multiplying my 4 outside in. 4 times 2, 8x. 4 times negative 6, negative 24. Right side again, I've like terms of negative 12 and 6, so negative 6x minus 3 will equal 8x minus 24. My smaller x term is going to be the negative 6x, so I'll add 6x to both sides. I have negative 3 will equal 8 plus 6, 14x minus 24. I'm now going to add 24 to both sides. 24 and negative 3, 21 will equal 14x. Dividing both sides by 14. 14 does not divide 21. 14, 28. However, we can reduce this improper fraction here. 7 divides 21 and 14. So reducing 21 over 14, we'd have 3 halves would equal x. If you want to write that as 1.5 or 1.5, that is also groove A. Example 3, we are going to multiply outside in by a f word, a fraction, 1/4 into 12x and to 16. So a fourth of 12, 12 divided by 4, 3x. A fourth of 16, 16 divided by 4 is 4. This will equal 10. I'm going to multiply negative 3 outside in, so minus 3x. And then minus 3 times minus 2 is plus 6. Left side, nothing to put together. Right side, 10 and 6 will make 16 minus 3x. That will still equal my left side of 3x plus 4. I'll move the smaller, colder x by adding 3x to both sides. 3x, 3x, 6x plus 4 will equal 16. minus 4, minus 4. I'll have 6x will equal 16 minus 4 will be 12. 6x equals 12, divide by 6, we'll have x is 2. One more of these fun examples, another fraction on the outside, as we can see here on the right side of my equation. Don't forget this minus 3 here. It means to multiply negative 3 outside in. So minus 3k, and then minus 3 times minus 4 is positive 12. That will equal 1/5 times 25 is 5, and then 1/5 of negative 5k would just be negative 1k. On the left side, I have numerical values of 21 and 12, which will make 33, and that'll equal 5 minus k. Smaller, colder k is the negative 3, so I'll add 3k to both sides. 33 will equal 5. 3 minus 1 plus 2. Okay. Subtract 5 from both sides. 33 minus 5, 28, will equal 2k. Divide by 2. 28 divided by 2, 14, will equal your k. Pause there, hit examples 5 and 6 are special cases, and then take a look at a perimeter geometry connection. Let's wrap up here daily number 3. Notes, we're going to take a look at special cases. Now what's going to happen here in examples 5 and 6 are my variable terms are going to cancel each other out. You're thinking, what? Cancel out? Watch and see here. As I look at the left side of my equation, I'm going to multiply my 3 outside into the x and the 2. So I'll have 3x plus 6 will equal 3x plus 4. Now our goal is to get the x's together on one side of the equation. So I have a 3x here and a 3x there. Well, which one is smaller? None. They're equal. So it doesn't matter which one I move. If I subtract 3x, subtract 3x, watch what happens. 3x minus 3x gone, 3x minus 3x gone. And I'm left with a statement, in this case, 6 equals 4. Now, this may be confusing, but what you're going to do is look at the statement and ask yourself, is it a true statement or a false statement? Hopefully we are all aware that 6 and 4 are not equal to each other. They are two different numbers. So if I ever get a false statement, I am going to state there are no real solutions. There is no number I can plug in for x so that the left and right side of the equations would be equal. On the other hand, if I look at example 6, when I multiply my 2 from the outside in, I'll have 2x plus 8 equals 2x plus 8. You should be seeing here that, ooh, it's an identical equation. Left and right side are the same. Subtract 2x from both sides. The x's are both going to cancel out. 2x minus 2x and 2x minus 2x are both wiped out, nothing. So I'll be left with 8 equals 8. This, my friends, is a true statement. 8 and 8 are the same. They are equal. So what I'm going to state here is that there are infinite solutions, meaning I can plug in any real number for x, and both the left and the right side are equal. So two ways you can write it. You can say all real numbers, meaning you can plug in any number you want for, in this case, x. and equivalent to all real numbers, infinite solution, since there are an infinite number of numerical values. Any number could be a solution. Infinite solutions. Those two statements are synonymous, same meaning, so either way you are covered. Perimeter geometry connection. We're going to look at examples 7 and 8. I'm going to give you the perimeter, the distance around the outside of the figure in example 7. The perimeter of this right triangle is 24 inches. That means if I add all three sides together, x plus 6 plus 8, that would need to sum add up to 24. 6 and 8 make 14. So I have x plus 14 is 24, subtract 14 from both sides, and I'm going to have x equals 10. So if my hypotenuse is 10 inches, 6 plus 8, 14, plus 10, 24. We are in business. Finally, I have a quadrilateral here. The perimeter, I'm told, is 39 meters. I have a left side of 5 meters, a top side of 12, a right side of x, and a bottom side of 14 meters. Those four sides need to sum or add up to 39. So my numerical values 5 and 12, 17, 17 and 14 is 31. So 31 plus x is 39. Subtract 31 from both sides, and I have 8 meters is going to be my missing side length. There we have it. Rock and roll, daily 3 in the books.